Hello everyone, welcome back to another video of this our community data behind data. I hope all of you are doing great. And first of all, I really missed to make these videos. The thing is that I got the opportunity to travel due to some work topics that I have to face, and that really disconnect me from various aspects of my life. But now I feel so happy to be here with you again to continue sharing with you all these knowledge videos and all the things that maybe can help you. Today I will bring back the last topic that we were talking about, that was data repositories, and for that we will be focusing on databases. So let's get started. Okay, so let's start by the first thing. What's a database? Basically, a database is a collection of data that is organized and centralized in a system that can be optimized for reading, updating, and analyzing. And while you might at first associate a database with a computer or a computer system, it can actually take many forms. For example, a shopping list, a address book. But it's important to keep in mind one key aspects of a database, and is that a database contains data that can be related to each other. Because for example, we have only phone numbers, it will remain just as phone numbers if we don't link those phone numbers to another thing, for example a customer name. And you will probably say, at what point do we have this physical I don't know, shopping list, address book into some systems that we associate with computers? Suppose that you want to store all the contacts of all your neighborhood. Maybe your neighborhood is composed by, I don't know, 20 people, 30 people. Now, throughout the years, you will be modifying manually the records of those elements that were added or were removed. And as you might probably realize, this is a process that is not optimized. This is not efficient. So here I want to ask you something. What would you prefer? To keep this process manually, or to have a computer where you can communicate with the database and just to say, okay, so delete this name of the person of this database? I don't know you, but I should prefer the second one, to have an optimized place where I can add and delete records every time that I want, and in an easy way. Getting in more technical words, we can have two types of databases: the relational databases or the non-relational databases. And let's start by talking about the relational databases. Relational databases, they are also called SQL because this is the query language that these databases use. And these relational databases are commonly associated with the data that is stored in tabular form, that is represented with columns and rows. And these columns and rows make entities, meaning that data is, structured data. So that's why it's important to first understand the different categories of data. And I know it's a lot of information, but let's take a step back and talk about what is an entity. Basically, an entity is an object, a person, a thing that is independent of another entity. For example, talking about business, we will have an entity of customers, we will have an entity of products, we will have another entity that will represent this, maybe the sales. But the important thing is that these entities are made from these attributes that are the columns of the data and the records of each instance of this entity. At this point, you might figure out the potential that these different entities has, and is that we can link and relate these different entities to gather a good composed information about something. Let's suppose that you, as the business owner of a store, you want to know which are the products that are more sold. If you have your customer table, then you have your products table, and then you have the sales one. You can link three of them to retrieve this whole information that you're looking for. And you might probably ask me, how can we link these entities if you said that they are independent each of other? And it's throughout something called keys. We have two keys. We have the primary keys and we have the foreign keys. And let's get back to the example that we were talking about, the customer's entity. The primary key basically is a column or a set of columns within a table whose values are unique. That's why if you can see at this table of customer, we have a attribute that is the ID, and this ID has to be unique to each of the records, and that ID or primary key is the thing that is gonna allow us to find the connection for that customer in another table. In the case that that customer went to the store maybe on Friday, in your sales table you're gonna find that maybe that product was bought, whatever timestamp, by the ID of the customer. And this is how we can link. And that primary key that was the customer ID then turns into a foreign key within the sales table. The primary key in another table turns into a foreign key, and each table has to have a primary key that needs to be and must to be unique. Now, talking about the non-relational databases, they are also known as NoSQL database. And the main difference between the relational and the non-relational ones are that the non-relational are more flexible and can handle semi-structured data, unstructured data, and also the structured data. Think about a non-relational database as a big flexible storage room where you can add anything that you want in any way that you want without having to organize this in a specific way. But this is not perfect. We will talk about that. We have four main types of non-relational databases. We have the key value store that stores the data in a way of keys and values as JSON files. Think about it. We have the document-based ones where basically the value is a JSON file. So it's like to have a JSONs, and within those JSONs we have another JSON. It's kind of it allows like more attributes within a attribute, within an entity. We have also the column-based one and the graph-based. And now we know where we can store our data in databases, but how can we communicate with this data within the databases? For that, it's important to keep clear and to understand the difference between a database itself and the system that is used to communicate with that database. Basically, the database is just the data itself. As we said, database is a collection of data that can be related to each other and that is stored in a system. While talking about the system that we use to manage it, is basically a software. Throughout this data is administrated, organized, and queried. And this software or system is called DBMS. That is Database Management System. So basically, a database management system is a software application designed for creating, maintaining, and interacting with a database. It allows for the storage, modification, and extraction of the data using something called query. Think of databases as bookshelves in a library where you can store data within them, and think about DBMS as the library guide that will help you to find the thing that you want, and that will keep those bookshelves in order and will keep the books or the data sorted in a certain kind of way, and will have this maintaining, uploading, and consulting topic in their hands. And I know what you're gonna ask me. At the end, just tell me which kind of databases should I use, a non-relational or a relational one. Leveraging that a non-relational accepts any kind of data, or leverage that relational database is kind of optimized for the structured data. That's something that we're gonna figure out in the next video. So make sure not to miss the next section of this one. And thanks to each of every one of you that are looking at this. I hope that I can make this kind of clear, and don't hesitate to put your comments below or any question that you have. Just stay data driven, stay focused, and see you in the next one. Bye. I never answer to no, man, I still go.